Welcome to another briefing. So in this briefing, per usual, I'm going to start out with the satellite image. And what we can see here mostly dry air mass. Another thing I want you to notice, if you can, is this clockwise flow that we're seeing off on, if you look at the winds, pretty much most levels of the troposphere today, but you can see this sort of clockwise circulation here. That is the classic anticyclonic flow associated with a high pressure system in the northern hemisphere. Okay, so this is like upper levels of the atmosphere. Let's just take the 500 millibar, 18,000 foot level, for instance. And you have this classic clockwise flow, which is an anticyclonic flow in the northern hemisphere. In the southern hemisphere, it's that would be a cyclonic flow, but I'm not going to get into that. I just want you to notice this kind of circulation. And another thing I want to point out is the surface winds they're blowing. The surface winds in coastal California, I should say, are blowing mostly northeast, and you can see what that does to the layer of fog offshore that forms because of the marine inversion. And the high pressure just presses down on that inversion, so the fog can become quite dense under high pressure if you had an onshore wind blowing in from the ocean. However, we have an offshore wind, so there's dense fog out over the ocean under that capping inversion of high pressure, where you have warm air above the cold ocean air, and that kind of just traps the fog in place there. But you have offshore winds, you have winds out of the northeast along coastal California. So that's why you have this fog being pushed out further offshore. The fog is not able to penetrate into coastal California because of these offshore winds. Now, if you want to understand, I like to demonstrate what's going on synoptically on a larger scale in the atmosphere that is causing this pattern and causing this winds. So I was talking about the 18,000 foot high pressure system. We call it a 500 millibar high, but I want to make this as understandable as possible for people that aren't meteorologists or weather enthusiasts. So I'm gonna show basically this is the pressure map at 18,000 feet. And I know this is a bit complex, but basically higher pressure, warmer air columns. Positive anomaly is going to be the red, orange colors. Lower pressure, colder air columns. Negative anomaly is going to be the blue colors. So you can notice here there's that big high I was talking about, parked off of the west coast of the U.S. And you see, even like at the 18,000 foot level, you also see pretty strong north winds. These wind barbs they're all blowing out of the north here. Yes, here we go. And you can see at the surface, same thing. You also have a surface high here, almost right in the same area as we were seeing that upper level high. And you have winds mostly out of the northeast. Look at these stations here or these observations along the California coast, northeast winds. My home here in the Bay Area has also been observing northeast winds all morning. My weather station here. So, there is clearly a pressure gradient with the high pressure off to the west and the low pressure to the southeast, roughly. That is giving us that northeast pressure gradient as wind does flow. I won't get into the specifics of it, even though I want to. I don't want to make it confusing. So basically, clockwise flow around high pressure, counterclockwise flow around low pressure. That's what's giving us that north wind, just for you to have an idea in terms of the weather pattern and why we're getting that north wind. Another thing to notice with this kind of pattern, back to the 18,000 foot level here, we look at this a lot because it's halfway up the troposphere where most of our weather occurs. And what we're seeing is what we call a blocking pattern, where so we're going to point out where the jet stream is here, was that river of fast winds that's separating the colder air from the warmer air, and it usually has most of our active weather is usually in that corridor. There are exceptions, but usually that's what happens. And so what we have here is we're noticing this big ridge over the west, bit of a trough over the middle of the country, middle of the United States here, and then you're noticing another ridge out over the east coast. And so if you look at the jet stream here, that you could basically think of the jet stream as the storm track. So you see this ridge is pushing the storm track well north into parts of central Canada here, and then it goes down into the Rockies. And actually a little bit, there's this trough. It's interesting because this trough is actually stretching a little bit into Southern California, bringing a little bit of cooler conditions, if you will, to parts of Southern California, while Northern California is under this ridge. It's also just bringing very, very dry air to most of California in general, as you you're basically taking this dry air over the mountains here and just spilling it down into these lower elevations of somewhere like California. And so now we're going to, I just wanted to show you real quick. I know this is a very complicated map also. This is a sounding. This is taken from balloon launches twice a day. Takes all kind of data, temperature, wind, humidity, etc., and then it plots it out on this what we call a skew-T diagram. And it's one of the fundamental tools that meteorologists and forecasters look at. And what I want to show you here, without getting too technical, is just a couple things. One of them is the winds. Notice how at the very lowest level here, I'll just give you a reference here, where I'm drawing this arrow. This is about 6,000 to 7,000 feet. Let's call it 6,500 feet up, roughly, just for you to have a reference. And so you're looking at the lowest 2,000 feet of the atmosphere here. Pretty light west winds, like very light wind out of the west. And you go just right above that layer, say in between 3,000 and 6,000 feet, you have winds over 20 miles an hour, or 20 knots. That's a much stronger wind out of the northeast. So you have quite a bit of wind shear down here, and you also have a pretty defined inversion layer where you have the radiational cooling that took place at night in this layer, and that's it's decoupling the atmosphere here in the lowest layers, which means there is an inversion here that formed at night. That means this air down here is not mixing with this air up here, and so therefore you have quite of a difference in the wind profile, and even in the moisture profile as well. I mean, it's dry, relatively dry at the surface, but it's even drier as you get above that inversion layer here. See, you get in here, so the dew point is in green. Look at how much lower the dew point is over here in that area where you have even stronger because we actually do have, this is at Oakland at 4 a.m. If you had a sounding from now, this wind here, what happens is the surface has warmed up, so this isn't separated anymore. This whole layer would be mixed, and so these winds would eventually mix down to the surface. So by now you probably have northeast winds here, but early in the morning that was not the case because we had that nocturnal inversion. And but I just wanted to point out how dry the air is here. You look at the dew point, look at how low it gets at roughly the 10,000 foot level. And it's pretty low all the way through the lower troposphere. This is very dry air. So, I mean, even if we had lift and dynamics, if we had plenty of instability and we had the lift, we wouldn't be able to form any rain or storms because the air is just too darn dry. Just looking at really dry air, this is just something to note for sure. And we're going to go on now to temperature guidance on the National Blend of Models. It takes all the computer model guidance we have and sort of blends it together. Forecast highs for the Bay Area today, mostly mid-70s. Some areas could be upper 70s, could be around 80. I would not be surprised if the warmest areas right at the downslope side of some of these mountains that might get extra warming with the northeast winds. Somewhere like southern Marin, where I am, coincidentally, the winds tend to go downslope on these hills here, and it compresses and warms the air. We end up getting even warmer than an area nearby that might be flatter. Yeah, mid to upper 70s definitely is what I'm expecting, given the day temperatures started out some areas in the low 60s, maybe even higher in the mountains. So yeah, I would definitely expect mid to upper 70s. If you look at the forecast low for tomorrow morning, some of these lows, I mean, yeah, 49 for Petaluma. Petaluma's pretty wind sheltered in a valley, so that makes sense. But I mean, you can see these shades of warmer colors here in some of these mountains, and I think in some of these lows might actually even be a little higher than these if you go up into the mountains or if you go into regions where you get a lot of that downslope warming. Because this morning, for instance, my place over here was 60. My sister's place, not far, actually out closer to the water, was 64 for a low. So it was a warm morning today, and it wouldn't surprise me if it's warm again tomorrow. Actually, let's put this slightly. So there's a different version of the National Blended Model that's slightly improved, and yeah, sure enough, it's showing warmer conditions up in the mountains. If I'm not mistaken, I think this accounts for climatology and historical error as well. So it's a bit, in my opinion, I think this is a bit more accurate in some cases, and I think that is the case for tomorrow morning. So let's just look at this model for the highs tomorrow as well, today and tomorrow, and it's a similar kind of, oh sorry, that's not today, that's way out. But tomorrow, I mean, look at this. I mean, I think these are both today and tomorrow will be similar in terms of highs. And this is even showing about 80 degrees for some spots here, like Concord, I think Livermore, San Jose. Half Moon Bay at 70, that's warm for Half Moon Bay. 75 for Monterey, this is very warm. 78 in Novato. Yeah, I mean, you're seeing close to 80 in a lot of spots here. Wouldn't surprise me if any of these spots end up hitting 80, maybe 81 or 82. So yeah, warm day. If you're into warm weather, enjoy it. If you're not, stay cool. And I mean, it might get a bit of a cool down early next week, but really not that much. On the National Blend of Models, it's showing it warming right back up as we go into the end of this week, into next weekend. Could even be maybe some 80s for the Central Valley. We'll have to see how that, like widespread mid 80s even. We'll have to see how that plays out. But looking quite warm, not looking like a lot of rain if you look at the long range model here. Unfortunately, this big ridge of high pressure sort of persists. You see the storm track continuing way to the north. To demonstrate here, this is the storm track. So Seattle, Portland will still get some good rain, but down here we're pretty dry. This cutoff system doesn't do much other than just bring a little bit of cooling, little bit of more dry wind for Southern California. It doesn't have enough moisture with it to do much in terms of rain. And then just like dry. Like maybe, Pacific Northwest will get rain. Maybe we'll get some occasional cirrus clouds from the spillover from the systems to up there, but not much here. This is looking way out on one deterministic model. I don't even like to show this far out, and that would maybe bring a little system, maybe some light rain to Northern California, but that's way far out at this point. It's really it's fantasy land, as we call it, so it's not worth really putting much attention into. The short term, what we want to be aware of is just more warm, dry conditions and some wind as well. Off and on breezy because of that high pressure setup that I showed previously. So that's all I have for today. I hope you're able to get something out of this. Thank you for watching, and I'll see you next time.